x1, x2 until xn be a random sample size of n, whereas x is normal distribution with parameter mean 0 and variance theta plus 1. Question A is to find distribution of new random variable y equals to x1 square using moment generating function technique. The solution for this question is firstly, moment of y t is equal to expected value of e to the power of ty. Change y with the given variable, which is x1 square. We're going to use integration formula to calculate the answer. The formula is integrating e value times with the distribution function x dx. Integrate e to the power of t x1 square times with the distribution function of normal distribution with the parameter mean 0 and variance theta plus 1. Then we can combine the power of e to get e to the power of t x1 square minus x1 square over 2 times theta plus 1. After that, take out the variable which is x1 square to get negative x1 square times with 1 over 2 times theta plus 1 minus with t, and simplify to get the same denominator, which is 2 times theta plus 1. The answer after simplify would be 1 minus 2t times theta plus 1 over with 2 theta plus 1. Then we take a look of the original of normal distribution, and we can see that the power of e value is in division, which is we must change our value from multiply to division. And to do so, we must swap the value of 1 minus 2t theta plus 1 with 2 theta plus 1 and get new equation, which is e to the power of negative x1 square divide with 2 theta plus 1 over 1 minus 2t theta plus 1. To get a simpler equation, we can bring it up the denominator on condition must added power of negative 1. Forget to mention the fraction. The original normal distribution is that sigma square root 2 pi. Since we already have a new variance, which is 1 minus 2t theta plus 1 to the power of negative 1, we must also change the variance in the fraction. But we must remember that if we're going to change the fraction, we must also change the top and the bottom of the fraction so that our equation is stable. In the bottom part of the fraction, we add new variance 1 minus 2t theta plus 1 to the power of negative 1 in the square root beside 2 pi theta plus 1. Also, we must add the upper part of the fraction, which is square root of our new variance, so that our equation is equal upper and the lower part of the fraction. The upper part of fraction, we're going to take it out so that we can calculate the rest of the equation from integration to the e value is equal to 1. And finally, the answer of moment yt is in the form of square root 1 minus 2t theta plus 1 power of negative 1. And we're going to change that square root into the form of power to get y minus 2t theta plus 1 to the power of 1 over 2. And back to the question is find the distribution of the new variable y. And we can conclude that the distribution y is equal to gamma distribution with the parameter alpha is 1 over 2 and theta is theta plus 1.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Bayanas. Next, let's move to the next question. For question B, we need to use the result that we find in A to find the distribution of new random variable w equal to xi square, total of xi square from 1 to n over theta plus 1. Hence, update the distribution of W and its corresponding parameter. So we decided to use MGF method. So first we can write the M new variable W T equal to expected of E power of TW. So with this W we can substitute it to this W value into the formula. So after this we can move theta plus 1 to the or move theta plus 1 to the left side. So then we can expand the total of xi square from 1 to n to this form, x1 square plus x2 square plus until xn square. So after this we can take this value t over theta plus 1 divide with each of this one value. So we get this value. Next we need to write it in MGF formula. So m x1 or x1 squared, we take it from this, and theta over t over t over theta plus 1 time with mx square x2 square with t over theta plus 1 and time until mxn square t over theta plus 1. Okay, next we can substitute the t value, this value, inside this the formula that we get from the question A. So we can insert the t value here, t, into this formula. So we get it like this. You can get it 1 minus 2 time with t over theta plus 1 time with theta plus 1 power of negative 1 over 2. We repeat it two times. Next, we can simplify this. We theta plus 1, we can cancel each other out because it's just the same value, same as this and same as this. So we get next we can get this value 1 minus 2t power of negative 1 over 2, same as the same value for the next formula, and until n time. So after this we can simplify it again. We can get it 1 minus 2t power of negative n over 2. From this value we can see that the value is from chi-square of MGF of chi-square. So we can denote as W for W follow chi-square with degree of freedom equal to n.
Question C is want to construct a 1 minus alpha 100% confident interval for theta based on the answer in question B. We know that the answer in B is chi-square n. Therefore, the solution is by using the estimation of variance theory. First of all, we construct P, W less than and more than. The less than part, we will put chi-square alpha over 2 and the degree of freedom is n. For the more than side, we put chi-square 1 minus alpha over 2 with degree of freedom is n. And all of that would be equals to 1 minus alpha. Then we're going to change W with the summation of xi square over theta plus 1. Next is divide both sides with summation of xi square. Now we have P chi-square 1 minus alpha over 2 n over summation of xi square more than 1 over theta plus 1 less than chi-square alpha over 2 and over summation of xi square equals to 1 minus alpha. Since we want to find confident interval for theta, we must swap 1 over theta plus 1 to get theta plus 1. With condition, we also must swap the value for both sides to get theta plus 1 is greater than summation xi square over chi-square alpha over 2 and theta plus 1 is less than summation xi square over chi-square 1 minus alpha over 2 and is equal to 1 minus alpha. After that, to get theta, we minus both sides and the final answer for this question is summation xi square over chi-square alpha over 2 and minus 1 and summation of xi square over chi-square 1 minus alpha over 2 n minus 1.
Now for the last question, question D. If total of xi square from 1 to n equal to 1000, n equal to 10 and alpha equal to 0.05, we need to find the interval estimate for theta. Okay, now we just substitute the value that we get in the question into the formula. So for this pi is 1000 over chi square 0.025, 10 minus 1 for the left side, and for the right side is 1000 over chi square with 0.975 and equal to 10 minus 1. So we can obtain the value in the statistical table. So the first value we get 20.483, for the second value is 3.247. We just solve the question. So we just get, for the lower bound is 47.8210 and the upper bound is 306.9766. So that's all from us. Thank you.